Okay, so for this one, it's giving us a couple of functions and asking us to find the composite of those functions and state the domain. So let me do the composite first. Oops, get that on draw. There we go. And so f of g of x, I think they wrote the other notation, but same thing. So for here, we're going to take g of x and put it inside all the x's of f. So that would look like 2x minus 3, that's my new x, and then minus 1. And putting those together, I get 2x minus 4. So for domain, there's a couple of pretty common things that we see. We see 1 over math, and then we see square root math. So we have domain problems that involve division, and we have domain problems that involve roots. There's other things too, but I think these are the ones that pop up right around here, so I'll just talk about both of them. If we have division, that's where we want to set that math basically not equal to 0. This can't come out to 0, so we solve for what numbers make it mess up. So if we had x plus 5 down there, we bring the 5 over, and we see x cannot equal negative 5. If we have a root, then what we need to do is we need to take that math, and it has to stay greater than or equal to 0, because remember, you can't take the root, an even root at least, of a negative number. So 0 to infinity is the domain of an even root function. So for this one, we just want to go 2x minus 4 is greater than or equal to 0, because we're just taking the math greater than or equal to 0. And then we solve that out, we get 2x is greater than or equal to 4, or x is greater than or equal to 2. So x greater than or equal to 2, and this wanted interval notation, so that would be 2 with a bracket because of the equal sign, and then out to infinity from there. And then to do the other direction, I think it also asks for g of f. So for that, we're putting f into g, and that would look like 2, and then this whole thing becomes that x minus 1, minus 3. So here there's all this stuff going on, but the only part that matters in terms of the domain is there's a root. So the stuff under the root has to stay greater than or equal to 0. Bring the 1 over, x is greater than or equal to 1, so from 1 to infinity.